Okay, let's talk about dictionaries. So we've already talked about lists, and lists are one type of data collection. Dictionaries are another type of data collection. Now, you'll remember in lists, we were talking about essentially an ordered list where everything had a index. We knew what the zeroth value was, what the first value was, what the second value was, so on and so forth. And we access that information through their index. Dictionary is also a collection of data, but instead of being an index list, this is actually a key value pairing. If you think of traditional dictionary, you would find a definition by first looking up the word. The word in this case being the key, the value being the definition. So if you want to look up a definition of a word, you go to the dictionary, you look at the key, and then read the definition, the key and the value. And that's how a dictionary is built. It isn't ordered, so we don't know what the first or last value is in a dictionary. Let's go ahead and look at a dictionary in code. So I've made a new Python file here called Dictionaries. So just as an example, we can go ahead and create an empty dictionary by writing the word empty or any word, whatever word we want to give the name of our dictionary, and then saying that equal to open and close. And you'll notice I'm using the squiggly brackets, right? That's important for dictionaries in Python. So this defines and initializes an empty dictionary. Now, as I said before, dictionaries are key value pairings. Let's look at another dictionary. Let's say I wanted to make a dictionary about a user. We could put in information about that user. Let's say their username. And when we do our keys, we want to make sure our keys are saved as strings like this, username. Then our key, whatever our key is quickly followed by a colon. And then we move on to whatever our value is. So our value in this case is going to be whatever we want the username to be. So in this case, we want the username to be, let's say, Rob. So our key is username, our value in this case is Rob, and that's a dictionary. Now, our dictionary could have more than one value in it. Let's say we are going to have a user's dictionary. And in this case, we wanted to have multiple users in our dictionary. We wanted to have user 1 was going to be Rob. Then we would separate each user by a comma, and then traditionally in Python, you might even use an enter, a return carriage to indicate that you're going to go on to the next one. So this was user 1. You might also have user 2. And that person's name is going to be Jeff. So on and so forth. So we could do multiple users in a dictionary. Although that particular structure might be better for a list. A dictionary is better when we have multiple pieces of information about one object. In this case, maybe our user also has a password. And that password is password. Why not? Whatever, right? Doesn't matter. So now we have a dictionary about one user, just one user, but it's got multiple pieces of information about that user. It's an entry about that user. And that's sort of where dictionaries are most useful, when we're storing multiple pieces of information about one thing, one object. In this case, username Rob. And again, we could use, it's more traditional to use a return here so that you start stacking things, and then actually this would go on the line below it. And that's often how you'll see dictionaries constructed in Python. So that's how we put information into a dictionary. What happens when we print out a dictionary? Let's go ahead and run our code and see what happens. So I want to run Python 3 dictionaries.py. And you'll see it prints out my dictionary here with my key names and my values. So there you go. There's our dictionary built in Python. Now, what if we wanted to get out one particular piece of information from our dictionary? What if I wanted to know of our user, what if I wanted to know just their username? You would actually pass it in square brackets like this, username. That's going to go into our dictionary and retrieve out just the username, which is Rob. So I'm passing in the key and getting out the value, key value, key value. In this case, the key is username, the value is Rob. I could do the same thing with password. And let's go ahead and change our password just so we can see the difference between the key and the value. 1, 2, 3, 4, 5, just like I have on my luggage. And then we hit up and we have 1, 2, 3, 4, 5. So we pass in the key password, we get out the value 1, 2, 3, 4, 5. What if we wanted to get out the user's address? Stop and think for a moment what might happen in this case. Once you've come up with a theory of what you think might happen in this case, go ahead and run your code and see what happens. We actually get an error, right? Key error address. What it's saying, what that line key error address, you can see it written here, means is that that's not a key in our dictionary. And we can confirm that. If we come up here and look, we've got two keys, username and password. Address isn't one of them. This is what makes this method of getting information out of a dictionary a little bit more dangerous. Well, what if we wanted to address that? We actually know a little bit about how to handle errors. So we could try this, and we could do except and just have it print key not in dictionary. Now when we run our program, it's not going to produce an error because we've done some error handling now with our try except block. And we just get out key is not in dictionary. That's a really good way of handling that error. But Python's actually already handled that error for us if we want to take advantage. So instead of using this method of the square brackets for getting information out of a dictionary, we can also use the built-in get method. So if we do user.get and we say username, or if we do print user.get, but this time we say when we know it doesn't exist, which is address. Let's see what these two statements get for us. The first one produces Rob. Great. The second one produces none because user get address does not have a value because address is not a part of this dictionary. So get is kind of a quick, easy way of doing that try except model, right? Except it's already built in. Python's already built it in for us in the function get. So we don't have to write our own try except block because the get method does the error handling for us. Dictionaries don't have to just hold single values though. And things can get interesting if complex if we have dictionaries start handling larger values like, let's say, a list. So let's make a dictionary here. We'll call it data. And we're going to have our data hold classes, let's say. So we're going to give it a value, a keyword called classes. And then we're going to pass in, using our square brackets, a list. So we might have math in our list. We might have science and English and history, right? Those all would appear in our list. So now, if we print data, we're going to see, and I'm going to go ahead and get rid of these first few things here so we don't muddy up our console. I'm going to clear our console. Then I'm going to run our file here. And now you'll see we get our dictionary, classes, math, science, English, history. So if I wanted to print out what classes I had, I could do data get, pass in the key classes, and let's see what we get out. We get out this list, math, science, English, history. But what if I just wanted one element out of that list? Well, after I do my .get, right immediately after, I can do square brackets just like I'm accessing a list. And then I can put in the index of the information I want. In this case, I want the first class. So if we're looking at our code, what should we get out? Math. And we can go from there. We could also do the second one in our list. Science, so on and so forth. So when you're accessing, you can save a list into a dictionary. When you're accessing elements of that dictionary, remember to start with the key to get the list, and then you can index into the list using this square bracket here. Vice versa, we could also put dictionaries into lists. So if I made a list of, let's say, food, and then in that list, maybe I put apples, but I can also put a dictionary with a key value pizza and with a list then maybe as the value that has cheese and pepperoni, something like that. So now we've got a list with a dictionary inside it, and that dictionary has a list inside of it. So we've got lots of nested things. And I really just want to show you, like, you can kind of put these data types together in any way that makes sense for your program. And often it's the combining of these various collection types that allows us to make more complex data types so that we can store and manage more complex data. And let's just see, what does this look like if we print food? We end up with this apples, pizza, cheese. We end up with all this. So what if particularly we want the first element of food? What does that look like? Should just be apples. Okay, what about that second element, which we know is a dictionary? What happens when we print that? We get this neat dictionary. What if I want to get inside that dictionary? Okay, well, now that I'm at the dictionary, I need, once again, to access that particular value inside the dictionary, which is pizza. So now I'm going to get the list cheese and pepperoni. And then if I want one of those two values, I have to go back to indexing like a list. Oops, not there though. After we do our get statement. And we get cheese. So you'll see we're flip-flopping back and forth here. We're accessing the list food to get to this dictionary. Inside the dictionary, we're using this key, which gets us to this list, and then we're indexing on that list to get to this particular value. So we've got lists inside of dictionaries inside of lists, and that's really just to show you that, again, you can combine these collection types. One other combination we haven't really talked about is what happens when we have a dictionary inside of a dictionary. So for example, if we have a dictionary inside, let's say we have a dictionary called users. And inside of users, maybe we have a key called admin. And inside of admin, we've got another dictionary. And that dictionary has the username, which is going to be Rob. And the password, which is going to be 1, 2, 3, 4, 5. And again, it'd probably be best if we did this and generally sort of tabbed over so that you can see the structure of our dictionary a little bit. And then as a second value to our dictionary, so kind of starting there, we might have non-admin, I don't know, right? And in non-admin, we're going to have another dictionary, and that's going to have some other combination of username and password. I'm just going to copy that for a second. But in this case, the username wouldn't be Rob. It might be, maybe Jeff isn't an admin, but he has the same password. Doesn't really matter. And in this case, you've got a dictionary with two dictionaries inside of it. So let's go ahead and print users. And we'll go through the process of accessing various parts of users. So let's say inside of users, I want to get the admin information. Okay, once we print that, let's see what that looks like. Okay, now we're down to username Rob and password 1, 2, 3, 4, 5. And then if I want to get the username, I'm going to use that same get command, but pass it username. And now I should be able to get the value Rob. So we've done dictionaries, lists with dictionaries inside of them, dictionaries with lists inside of them, dictionaries with dictionaries inside of them, dictionaries with lists inside of them, all those combinations. And it's really in the combination that we start being able to make more and more complex structures that are more interesting. And especially when we start mixing things, you can have a dictionary that's going to have a couple of different things going on inside of it. And you'll start to see as you get more complex in your CS career, how when you're accessing things like APIs and whatnot, the information you're getting back is often going to be structured with these kinds of combinations. Sometimes it's a list, sometimes it's a single value, sometimes a value in a dictionary has another dictionary inside of it. So I just wanted you to kind of be aware of how these all work. But this is basically dictionaries.